All right, so here we are, section 4.5. I really hope you watched the pre-lesson because that's where I explained all of this in great detail, and it will just make so much more sense if you take the time and watch the pre-lesson. However, we're going to dive right in. Assuming that x and y are positive, write the expression as a sum, difference, or multiples of logarithms. Here's the deal. I talked about you got a log, and sometimes you're going to hit it with this big maul, and you're going to split that log into two logs. I'm not much of an artist, but there's half a log. Oh, that's terrible. Anyways, let me try it again. Boom, boom, boom. Oh, here we go. Feeling it. So there it is. All right, there's a log cut in half, but you're going to have two of these. You're going to split them in half. What do you mean? Well, you notice these two things are connected by multiplication. That's the maul. You're going to write it like this. Done. You just split the maul. Excuse me, you split the log. My bad. All right, this is division. What's the rule that I taught you? Well, that's going to turn into the top one minus the bottom one. See, you just got the maul. You split the one log into two logs. Keep it that simple. Now, this one is law 3. Just law 3. There's not a whole lot you can do with this. So I don't even like this problem being written in this section. But we're going to take that negative 2 and we're just going to throw it in the front. And you're done. Okay? Now, I got a funny feeling that the author of this problem, though, wanted you to go like this first and just go, oh, it's one like that. But then, see, this makes it a lot harder. And see, now this turns in, but it's good to talk about. This turns into log 2, 1 minus log base 2x squared. And here's an interesting thing. You see this 1 in this position? Every single time you have a 1 in that spot, this logarithm is going to equal 0. Why? Because 2 to the 0 power equals what? 1. So anytime you get a 1 there, it's like this log just disappears. And now I can bring that 2 in the front, and I'm going to get negative 2 log 2x. See, that's the same as this. But if you use law 3 first, it just makes your life a lot easier. All right, this one. These two things are connected by multiplication. Some of you might be looking at that thing. I just said use law 3 first. Here's the thing. That 3 only attaches itself to the y. So I'm ignoring it. I'm concentrating on the multiplication. I'm getting my maul out, and I just split the two logs, or the one log into two. And so now here's a weird thing. You actually just followed the instructions. So you could argue, I'm done because I did what they asked. But they want you to be aware of law 3, so practice law 3. In other words, I'm going to bring that in the front. This thing doesn't have anything to do with it. So, whoops, it's not base x. And then plus 3 log base y. And now I've got my answer right there. All right, this one's got its own little twist. Once again, multiplication. So I'm going to separate it into 1,000 plus log x to the 4. And I'm done. But pre-calc isn't going to be that nice. They're just not. I'm pleased that you know the rule, okay? Multiplication is addition. But now pre-calc is going to push you a little bit harder. Isn't there a little invisible 10 here? And if I looked at this and I said, hey, what even is it? You should be able to transition this thing into one of these things and then ask yourself, 10 to what power is 1,000? And you'd go, aha, that thing equals 3. That's tricky. It just is, because it's new. You guys aren't used to it. And it's kind of an expectation that's not explained in the instructions. But I just told you. So if this is a 10 or a 100 or 1,000 or 10,000 and you got a base 10, you got to keep going with it and simplify it. And then like I said over here, practice law 3. That 4 can come in the front. So that'd be 4 log x. And you're done. All right, so we're going to start with the rule that's jumping out at me, and that's this guy right here. What does division mean? Subtraction. So it's the natural log cubic root of x minus the natural log cubic root of y. And I think this is what breaks people. It's like, listen, I just followed the instructions. I took the one log, I split it, I'm done. And then pre-calc just pushes you a little bit farther because they want you to understand that this is the same thing as this, because the cubic root is the same thing as 1/3 power, and then this can go in the front based on law 3. And I'm just going to be honest with you, this is an excellent ACT or SAT question, and that they might go A, B, or C, and then guess what letter D is? All of them. And they're all correct. But this is the one pre-calc is going to want you to get to, just because it forces you to practice everything. Okay, this one's easier than the previous ones, I think. Now it's saying, write the expression as a single logarithm. So really now we need to go in reverse. What does addition mean? Multiplication. So it's just log. I could say x5, but math just doesn't do that. I'm going to go sharpen my pencil. There we go. And now we got subtraction. So that means division, but the 2 shall become 1. That's a little quote that I come up with. So when the instructions are like this, I think the 2 shall become 1. I call it the marriage or marriage from Princess Bride. And this is just my mall. All right. So anyways, subtraction means division. And I go like this. Done. It's that easy sometimes. This guy, it already is a single log. So what do they want you to practice? Law 3. What does that mean? That 1/5 goes up top. And I would write it like this. Log z to the 1/5. And I can say I'm done. But that also equals the 5th root of z. I'm curious which one pre-calc is going to want you to get. Okay? But if you're on a test or a quiz and you put one of these things, they're both fine. All right, so this one, step number 1, see that 4? That is law 3 just begging for your attention. So you're going to think of it like this. Before the 2 shall become 1. So what does subtraction mean? It's marriage. The 2 logs shall become 1. So I've got y to the 4th all over z. All right. Again, law 3 is sitting right there. Where does it go? Right here. And now I'm going to use some old algebra rules. Got a little excited there. Couldn't talk. X to the 9th, y cubed. I'm going to do the same thing here. Put it there. Plus natural log. There's an invisible 1 right there. So it's y squared z to the 4th. Now what does addition mean? Addition means multiplication. The 2 shall become 1. So it turns into the natural log of x to the 9th. Y squared times y to the 3rd is y to the 5th. There's an old algebra review. And then z is by itself. Let's see if there's something on the back. Yes, there is. Okay. Now this problem says use the change of base formula in your calculator to evaluate the logarithm. Now, I'm not going to use the change of base formula because I want you to see what's going on. So this is simply something you've been doing. It's just not a very neat and tidy problem. So this says 5 to some power equals 19. You see that? And so now it says common bases, happy places. Well, this is impossible, okay? So what you're going to do in a situation like this, and this is where you guys are going to see the benefit of logarithms, and I've got this long, goofy, well, let's just do it this way. 2 to the x equals 2 to the 3rd. See a problem like that? You go, hey, x is 3. See, common bases, happy places. That is not going to happen, right? Now, what if I had 2x plus 3 equals 6? If I subtract 3 from both sides, isn't that mathematically okay? Yes. Now, everyone repeat after me. This is a chili problem. This is a chili problem. What are you going to do? Well, you're going to put a log on the fire. Watch, 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 watch. You're going to put a log on there, and you're going to put a log on there. Why would I do that? Because now, in the world of logarithms, the thing I'm trying to find is in the exponent position. I can bring it into the front. And basically, this is the change of base formula with understanding. And I like this better. I just do. So the x goes in the front times log of 5 equals log of 19. Now guess what? Now we're going to use our calculator. We're going to go log of 5, enter, 0.698. So 0.698x equals, now I'm going to find the log of 19. Hit enter, that's 1 point, I'll just round it, 1.23. Now I got to divide by 0.698, both of them. So divided by 0.698, enter. So I get 1.83. And that is what x equals. So 5 to the 1.83 equals 19. Now think about this. What's 5 squared? 25. So does it make sense that 5 to the 1.83 would equal 19? Yeah, kind of does. And slapping those logs on is something new. And it's a skill that I want you guys to be aware of. That's why I'm not showing you the change of base formula. I want you to understand you can put logs on the fire if you get something crazy, okay? Now, I'm going to hit pause so I can transfer the little formulas right over to this section. All right, so on the front of this sheet are these two little conversion formulas, which are found right here. I just wanted to transfer them and save a little bit of time. I don't see much of a point to these exercises other than can you follow a formula. So it wants this in terms of natural logs, which means follow this formula right here. So they're saying b is 3 and x, the thing in your x position is just your x. So put things where it belongs. So you're going to go ln x all over ln b. Common log, it's the same thing, but now you got the log, which is considered the common log, x, all over log b. So in this one, we've got here, that's your b, and this stuff is what would be referred to as your x. So if we just followed the formula for natural logs, we'd go ln all of this stuff, x minus y, all over ln b, which is 1/3. And then for common logs, it'd be the same thing. log x minus y, log 1/3. Again, I don't see a lot of value in this. So for a problem like this is what I really want you guys to get. Try to figure that out. You know, if it was 2 to the x equals 8, you'd go, 2 to the x equals 2 cubed, so x is 3. Or you could just use common sense. There's no way you're using common sense on this. So on problems like this, remember, this is a mathematically chilly problem. So this is where you're going to slap a log on the fire, slap a log on the fire. With what purpose? The thing you're trying to find, you can bring it down the front. And then, I'm not going to finish this for you, but then you can figure out what this is as a number by using your calculator, figure out what this is as a number using your calculator, and then just kind of keep doing the math, and you'll figure out what x is. And there's no way you could figure this out without slapping a log on the fire. That's the benefit of these crazy little logarithms. There you go.